All right, so we are doing two-sided tests from you today. All right, one of the biggest things with this that kids get really confused with is, like, what is the whole point in doing a two-sided test? So, for example, have you guys ever played the Don't Break the Ice game? All right, that's the one with the little plastic hammer where you got to hit it, and you want some of the ice cubes to fall, but not all of them. Basically, you don't want to drown the penguin. All right, so what's going to end up happening is we're going to go through and measure and see how far off our ice cubes are. No, we're measuring. Yeah, it's squishy. All right, so this is, you guys see this box over here on the right? This is Minitab. It's not something you'll typically see in like a high school or even entry-level college stats class. It's one of those like super nerdy softwares. It's got its purpose, but it's a different way of showing it. So what you see over here, this first one is your mean. See how it says S1 and then it's whatever shows up first? That is your mean. All right. Second one is the count. So they did a sample of 50. Third one is standard deviation. Fourth one is standard error. So I go through and I kind of color code. You could draw arrows. It's kind of whatever floats your boat. All right. So basically, you are the supervisor working at the factory where they are designing the little ice cubes. And you need to figure out if your ice cubes are too far off. Because if they're too far off, you can't fit them all in the little thing. And then you go to hit the hammer, and they either don't fall or none of them kept together at the beginning. So no matter what, your penguin is dead. It has been eaten by Shamu. Everything is gone. You guys don't know who Shamu is? He's an orca. They used to have him at SeaWorld. And I think he was in Free Willy. There used to be a SeaWorld in Ohio. I know this because I accidentally shut it down as a toddler. Because, no, I ran away from my parents and they had to lock down the entire theme park and look for me. Yeah.
Where did you go?
The SeaWorld in Ohio. No, I mean, like, where did you go? Oh, so there was this whole little slide area, and I was getting pissed because my parents weren't letting me go on anything fun because my dad is afraid of heights, and my mom gets motion sickness, and my brother was 2. And so here's 5-year-old me, very bitter about you took me somewhere with roller coasters, and you're not letting me go on any of the roller coasters, so I'm going to fight you. So I go to push my brother down the slide, and this lady knocks me out of the way to shove her kid down, so I'm like, perfect timing. I'm running. I crawled under 4 barricades past 3 employees to this whole little area where they had all these punching bags and then this big rope, like, not really ladder, but it was just like the rope grid, like, that you crawl across. That's where they found me. Well, this was the little kids run around area where your kids are just driving you nuts and you just send them. Oh, yeah. This was before Amber Alerts. They could have very well had a Danielle alert because of me running away. Yeah.
That would be pretty cool to say. The reason why.
Yeah, Amber Alerts or Danielle Alerts, it's my fault. Yeah, it was all fun and games until they sent like a 20-year-old up to get me, and he literally came up there and he's like, if you don't get this down here, your mom's gonna beat both of us. Go. And I'm like, I'm scared. And he literally just grabbed me and was like, you're coming with me, kid, and just took me, and I like, yeah. He's like, she's gonna beat both of us. And I'm like, oh yeah. I got my butt whooped all the way out to the car. I remember that. Oh, yeah, my mom would always tell me, you want to go out to the car? We can go out to the car. Oh, yeah. Yeah, my mom did that to me once, and then she dropped the F-bomb, and I was like, oh, I had to have soap because I called Dustin a butthead. You used the no-no word, like the epitome of the no-no words. You get soap, too, and then I never got soap in the mouth again. So. All right, so standard deviation. They give me a standard deviation of 0.09, and that is for the population. All right, it's basically how far away from the mean we are. Bless you. All right, the standard error that they gave us, which is the, yeah, 0.013. That is for the, that's the standard deviation for the sample. All right. And it's basically measuring how far off everything is within my sample. All right. So what are two possible reasons why my mean for my sample of 50 little plastic ice cubes is not 29.5, it's 29.4846? What are some possible reasons why my measurement would be off? All right, I grabbed too small of a sample. Yep. There's a problem with the machine, and they are actually that tiny. Scroll. Thank you. Could there be a problem with the device I am using to measure things? All right, so most of the time we call those dial calipers. So yes, there could definitely be a problem with my measuring device. All right. Most of the time, I'm a little concerned that there could actually be a problem with the machine. Now, for some reason, I did not plan this out properly and do enough room for this. So, we're going to go real tiny. All right, we got to start with our checks. So, was it random? Yeah, they set up there that it was randomly done. All right, second one is going to be, was it normal? Did they say it was normal? I was going to say, read through that paragraph. We're just looking for the one word of, it's normally distributed. Nope. So I always check the normal first. So normal fails, but my n is definitely greater than or equal to 30. So that clears that. Yeah. And then last one, independence. All right. Does it matter what the first cube is? Does it have any impact on the second cube? Nope. So we're good. Yes. Normal distribution failed, so we have to go large counts. 10% of the population, I mean, think about how many little ice cubes they're making. We've definitely cleared that one. Yeah.
And the NP, is that for proportions?
NP is only for proportions. So when I go to make up my idiot's guide for it, I'm going to do means and proportions, and then I'll have options like for different tests. What are the checks you need to do? Which test is it in the calculator? Like which buttons do you hit? So I idiot-proof all that when I go through and write it. And then if you guys want to write your own, we could compare. And if I have something that you don't, we can mush them all together. Read mine first? Okay. All right, so I'm definitely going to have to do some kind of test. Am I going to use a z-test or a t-test? Z. Why z? Yep, so it's a z-test. Two main reasons. N is greater than 30. Second reason is I have my standard deviation. I'm just kind of jam-packing this in there. All right, so what kind of null and alternative hypotheses do I want to have? Okay. And then alternative is, yes, this is the two-sided. So 29.5, it's not equal to that. All right, calculator time. That is definitely right. No, you can hear the rain on top too. It's dumping. Oh yeah. I can send you guys a picture of my neighbor's backyard when all the ducks show up for the pond that forms. And Mina loses her crap. Oh, the poor Poop 911 guys come in today. I'm so sorry. We have a service called Poop 911 where they come and get all the dog dookie because I'm stretched to the max and I'm like, no, I ain't got time for that. So I hire somebody to come and scoop dog poop for like $12 a week. It's a whole service. Except I have 3 dogs at my house. So I texted them last night and was like, FYI, you need to up me because Maggie's 90 pounds of fluff, but between her and Mina and Ellie, there's poo everywhere. Yeah. And they're going out in the rain, like, I should just give them hazard pay. I know, I feel so bad. Well, and Ellie's got kidney disease, so her poo is something special. I know. Wet poop. Alright, so, we are going stat, tests. We said we were going to run a z-test, so that is number 1. Alright, we are doing it not from data, but from statistics. Alright, so mu naught is what we believe everything should be. So that should be the 29.5. Now, the standard deviation, they give it to us. That's that 0.09 that we used from earlier. So 0.09. I say we just round it to 0.09 because the next 3 are zeros anyway. All right. X bar was the 29.4846. All right. What does? Yeah, that was you drawing on your paper because I color coded. All right. N was 50. And then we are looking at mean does not equal mu naught. I'm not drawing the stupid thing, so I'm just going to calculate it. Calculate. Because they just gave me the standard error. I don't know if that's from that sample. So normally you do the standard deviation for the sample divided by the square root of the sample size. Remember all that? This thingy? That's why. Oh, you're liking this? Okay. So, you're like, something went very wrong. Put that the sample size is 124. What's the sample size? 50. See? All fixed. Yeah, so my p-value is way higher. So we failed to reject.
Small p.
Yeah. Small p, we reject. We failed to reject the p. All right, so p-value is 0.226.
Do we ever need to use the z-value?
Not really.
So you just use the z-value to calculate the p-value?
Why wouldn't I just use a calculator? All right, so alpha is definitely less than my p-value. So it is we failed to reject. The null hypothesis, we do not. Bless you. All right, so we're just going to put in there that we don't have any convincing evidence that the ice cubes are off in shape. Because remember, if they're too big, problem. If they're too tiny, also problem. I don't know. I think it's going to be like all frickin' day with the rain. All right, so for this next part, we've got to go through and find an actual confidence interval. So we're going to run a Z interval. Yup. Here's your radar. Yeah, we're getting slammed today. It's gonna be a while. So, when you run a Z interval, it's stat, tests, Z interval is number 7. It actually, because your calculator can be kind of smart sometimes, it'll actually enter stuff from before.
Who's the lady that invented the calculator again?
Edith something, right?
Thank you, Edith.
Yes.
Wasn't that a national Edith Day?
We should have National Edith Day. We do so many things for old dead dudes just to appease them, but Edith saved our lives with the freaking calculators. Let's be real.
Hey, let's make it happen. Let's make it today. Today is National Edith Day.
Okay, March 3rd is officially National Edith Day. I will write this down. Or at least Grove City High School's Edith Day. We could do Edith Week for the calculators.
Yeah. You know,
I like Edith Week. They do.
Except financial calculators.
Financial calculators can bite me. Alright, so I've gone through, I've run my whole little Z interval, and my Z interval is going from, oh, you stupid thing.
You're gonna have the p-value is
29 point what? 54?
5.1.
51.
Now that don't.
Hang on. So we got the numbers from right here. If you run the Z interval, and make sure you change it to a 95% confidence interval, not a 99. All right. So is my X bar within the interval? Yes. Is 29.5 also in that interval? It goes slightly, I mean, if you think about this, we're going hundredths off. These are almost immeasurable. Yeah, it has to be very, very close. But you've never seen this game? Okay. That could make a difference. Hang on. This game? So these are hexagon ones, but they make them with rectangular ones as well. So basically the entire purpose behind this is you place the penguin somewhere, and you and the person across from you spin the spinner so you know how many ice cubes you have to break by certain colors. And your goal is to break the ice cubes out of the ice, but not drown the penguin. It's little kid Jenga. No, this is toddlers.
I think I got something like this for Christmas, like when I was a little kid, but my parents clearly got the Amazon knockoff, and it was like a polar bear, I think. And, but on the box it just says ice game.
Yeah, just like a little drink.
Oh, is this the polar bear one?
Yeah, that's what
Yeah.
No, but that is similar to that, but it just said ice game on it.
Ice game. Okay.
With that one, you don't have to spend anything.
Yeah, you're hitting ice cubes.
It's terrible.
All right. So does our interval support our decision that we don't have convincing evidence that it's too far off?
Yes.
Why would you say yes and no?
Because both the alternative and
Okay, so you're saying because both fit, like the 2.5 or 29.5 and our X bar of are both in there?
yes. And then
Yeah.
yes, because it has
We're going to be okay. We did, but what we've done now is we've run a confidence interval. So what was it? Yesterday or the day before we were talking about confidence intervals, giving you a little bit more wiggle room when you go to make your claim. Right now what we're trying to look at is, does the confidence interval tell us anything outside of what we already thought? We already thought you're pretty doggone close. mu. Yeah, that is what I believe everything has for a size. So X bar is from my sample, like my little sample that I took is still in here, and so is the mean for the actual population, like where everything should be. So Clay's pointing out that because both of the numbers are in there, like it doesn't clarify anything further. Like it doesn't make it so you're like, yep, you murdered these people. Like, it's just, eh. Yeah, it kind of goes against it. On the yes part, like you could say, well, both numbers are in there. So, I'm not too far outside of the realm of possibilities. I could still get a smaller sample, but still be okay. So literally, your explanation for this could go either way. It's depending on how you kind of back it up with evidence. My answer key? I just wrote down the interval. If I remember correctly, yeah, if I remember correctly when I did this, where's my old ones? Because I have them right here. Yeah, I just wrote on there, it kind of depends on what justification you use. Like, okay, yeah, it kind of supports it, and no, it kind of doesn't. Like, it muddies the water a little bit. Whatever kind of justification you use on that, that's however you view it. Alright, let's keep going. Data! So, for this is actually a two-mean test. So, yeah, we're going to be fine. I gave you a ton of space on this one. So, we're going to test to see, is one lane faster? You guys remember the express lane at the grocery store? Is that still like the 10 items or less? Some of them are? Okay.
Most of them is called like self-checkout now.
Yeah, they've gone to self-checkout. There is one at IKEA.
They self-checkout time because they can't guarantee you it's express, so that's why we're probably going to figure it out.
It's not faster. Oh, Karens. Okay. Gotta love them. Yeah. Ruin everything. So, to collect their data, they randomly selected 15 times during the week. Okay, so random is important. 15 times, okay, that's my sample size, so that's kind of tiny. They went to the same store, they bought the same singular item. So they bought one item and they tried to see which line they could get through faster. So we've got all of our data for the express lane here, and then I've got all of my data for the regular lane here. Huh? Like express and regular? Yeah. Express, regular. I was going to say, it also is labeled up there. Yeah, you do you. It's Friday. Our brains have stopped. All right. So, they're going through, they bought the one item, except one of them used the express lane and one of them used regular because they went at the exact same times. All right, so to decide which lane each of them used, they flipped a coin. Cool, Libby used the express lane, Catherine used regular. I really don't care about all this part, do I?
Nope.
Like, I don't care that you flipped a coin. That's great that you did it, but I just don't care right now.
There's a problem.
No, there is. All right. I'm still working on reading. Hang on. We're going to get to it in a minute. Okay. So they entered the randomly assigned lanes at the same time and then recorded how much time it took them. Carry out a test to see if there is convincing evidence that the express lane is faster. Okay? So, when we go to do this, we're going to go through and actually do regular minus the express lane. All right? And the reason we're going to do that is because if it is the regular lane minus the express lane, if the express lane actually is faster, what should this number be? Positive. Okay? Regular should take more, like if it takes me 10 minutes to go through regular and it takes me 3 minutes to go through express, it should be a positive number. All right? Now this is if the express lane is faster. Right? If the express lane is slower, it's going to be a negative number. Does that make sense? So, I'm going to say that my null is going to be that express minus regular, not express, regular minus express. Regular minus express equals 0. Why do I want it to equal 0? Yeah, they're the same. There's no difference between the regular lane or the express lane. They have lied to you. All right. Alternative, because I want it to be positive. Yep, regular minus express is going to be greater than 0, because that leaves it as a positive. All right, so this is actually, we're going to get into what happens when one of the conditions fail. So, am I going to run a z-test or a t-test? Yes, I need to run a t-test. And the reason for that is because, yeah, n is less than 30. You're doing like a matched pairs test. Yep. So, random. Okay. Was my sample size big enough? Sad face. All right. N is definitely pretty tiny. Yeah. So n is less than 30. So I would say proceed with caution. I would also say let's maybe graph it so we can make sure, like, because I don't know if it's going to be normal, because it does have such a tiny... We are going to turn on 2 plots. So we're going to go stat, edit. I got to clear all of this crap from yesterday. And that's how it used to be at most grocery stores. Yeah, like 12 items or less, 13 items. Yeah, but a lot of times people could be buying 20 candy bars. They're little items. They're quick to scan. Now, if you're buying 20 things of water, you won't be there for a hot minute. Spoilers. 456, 529. Turn on list 1 and list 2.
We can't do this one.
Actually, we can.
Blue one's pretty.
So when you're right here, you hit second stat, and it'll give you all of your lists in there. Okay. So I can hit zoom, stat. My red one goes up kind of high, doesn't it? Now remember, what's the big thing we're actually testing for? The difference. Second stat. Hit zoom 9. Not yet. So, hang on. I have a method to my madness. Let me do it. All right. So if I go back into my lists, all right, is there a way to do list 3 is list 1 minus list 2? How? Yeah, so if you kick it up, I believe if you go up, and I would just watch me real quick while I do this, list 1 minus second list 2. Hey, I'm a genius. All right, so no touchy the buttons, just watch. Go to the list you want to dump it in, which is list 3. Go up to the top, because normally this is where we hit clear, yes? Now remember, we hit second list to get all of our different lists. So hit second list. I want to do list 1 minus second stat, list 2. Hit enter. Magic. Did you hit enter? Yeah, but sometimes if you hit enter or on while it's doing it, it'll actually pause it. Yeah, you got a spinning wheel deck. There you go. You hit enter, and then sometimes if it's graphed, if you hit enter again, you can turn it off. All right, so let's do one better. We've already graphed these two as a stat plot to see if there's any kind of difference. Let's graph our stat plot for list 3. So I'm going to turn off that one. Second, enter, list 3. Because you have to hit zoom 9. Turn off plot 2, change plot 1 to be list 3. And then hit zoom 9 because we just changed all of our data points. Jocelyn's got you? Okay. Well, so yeah, I would look at that kind of left whisker. That's a little hefty. Because I go from negative 30, negative 95 to negative 250. So this is why we want to kind of proceed with caution right here. I don't think you have one this bad on the test. All right, so normal. This is kind of the normal part, / normal. We're going to say proceed with caution. The negative 246 might be an outlier. All right, and then is the sample less than 10% of the population? That's that independence piece. Yeah. It's also so I can be sneaky and teach you some tricks in the calculator. All right, independence we're okay with. / what's that called? N is 10%. Or is less than 10% of population. Yes, we are good. All right, so are we ready to run the t-test? Yeah, it takes longer when you actually have data. Hey, giggles. Shh. I already got the fan. It makes it loud. All right, so now I'm going to run a t-test. Do I want to run it off of stats or do I want to run it off the data? Data. All right, so get out of here. Stat, tests. I'm just running a plain old t-test. And I'm going to actually run it off of the data. And data, what I actually want is in list 3. All right, we said the mean should be 0. So data is when you have a list of data. Stats are they just give you what the mean and the standard deviation are. Yeah, they give it to you in the words. Basically, if they give you a list of numbers, you're probably going data. All right. Now, which of these 3 are we actually going to want? Greater than the mu naught? But if it's less, that's proving that the regular lane is faster than the express lane. Yep. Yikes. Now what do we get? Yeah. That X bar out of negative 40. Yeah, because remember, we're going regular minus the express. This is showing me my express lane's not actually faster. Mm-hmm. All right, so p-value. Which was 0.96. Yeah, so that's definitely part of it. The express lane, you also get like the little old people that work at it. And they're just like, we're going to sit and talk. And it's like, homie, I want express lane for a reason. Get me out of here. All right, so now that I've done all this, we are going to end up rejecting our null hypotheses that there is actually a positive difference. All right, so we are rejecting. No, we fail to reject on this one, don't we? Yeah, big P. So we're going to fail to reject it, which means we do not have no evidence that express lane is faster. Okie dokie. I wouldn't necessarily blame it on the customers. It could be the different cashiers. Maybe on the express lanes, they put all the people that they're going to train. We don't know that. All right. I think that's it for this page. On this last page. So, hang on, we're almost done. Is there a difference between practical significance and actual statistical significance? Yeah, one's proven by data. Another one is you can just frickin' tell. All right, so this is provable with math. Can be backed up with math. Proved with math. Proven with math. Whatever. I just wrote prove and then able at the end. It's like, I call it. All right, practical significance is, any moron with 2 brain cells can see it, maybe? Common sense, yes. Have you guys heard the theory that orange cats only share like 2 brain cells with other orange cats and someone gets custody of it? Pretty much. All right, so what do you think the problem is with doing multiple tests trying to do the same thing? Okay, results can differ. Does it take a lot of time to run multiple tests? So a ton of time. All right. Yeah, if it's your job, fine. But remember, we watched that whole p-hacking video where they only ran the test once. All right. The big issue is you don't necessarily get funding if you're running multiple tests to kind of back everything up. All right. We're going to skip that next one because we don't have to really worry about power. What? Power? Provable is a word? Cool. Actually, this one's super easy. Yeah. So this last one is quite literally you take your alpha value and then, yeah, you raise it to the exponent. So it's 0.05 to the 20th power, which is 9e negative 27. No, I have it written over here. I'm good. All right, so probability of type 1. Now remember, this is over 20 tests, right? So if I run 20 different tests, checking the ice cubes or checking the express lane or anything like that, I have a stupid level of tiny type 1 error possibility. Yeah, that's type 1. The probability that avoid type 1. So we do not get a type 1 error.
Wait, so the probability that we avoid a type 1 error, so there is a 90.
I would say it's probably, I think the wording's on this crappy. Probability that we avoid a type 1 error. Yeah, it's probability that we can stay away from a type 1 error in all 20 tests.
Right, so you're most likely going to have a type 1 error.
Well, look at my probability is basically 0.
So you're going to
No, I'm not going to have one. The probability that I do not have a type 1 error. Yeah, I know. I don't like the wording either. Don't worry about it.
So the probability that you will, it should say the probability you will have a type 1 error is 0% because you most likely.
Yes. Frickin' English. I think that should be like on the notes for stats is if reading is hard, don't take stats.